Hello, everyone. My name is Polina, and I'm a content strategist at KML Vision. Today, we're going to speak with some of the authors of their publication, Automated Data Adaptation for the Segmentation of Medical Images. Let me introduce them. Andreas Haghofer is a researcher at the University of Applied Sciences, Upper Austria, and a PhD student at the Johannes Kepler University in Linz. He specializes in medical image analysis, machine learning, data science, and computer vision. Hello, Andres. Great to see you.
Hello, thank you for the invitation.
And Thomas Ebner, my colleague and a computer vision and machine learning engineer at KML Vision. Hi, Tom.
Hi, Paulina. Thank you for the introduction.
So let's dive into the details of this paper. Tom, first question to you. Can you please tell us what motivated this research?
Here at KML Vision, I'm working a lot on the development of AI-based segmentation methods. In order to train such segmentation methods, having a large variety of training images is quite essential. However, in the biomedical domain, it is often not possible to obtain such large datasets, or it is simply very expensive. Therefore, when you train on such smaller datasets, your trained model might lack robustness to domain shifts.
Okay. Could you give us an example of a domain shift, please?
One example of a domain shift would be that you train your model on images from one laboratory and then use this model to segment images from a different laboratory. So if the two laboratories have different imaging characteristics, for example, if they use slightly different staining methods or a different microscope, then your images might have different colors or noise levels, and this is then called domain shift, which is quite challenging for the model to produce accurate results on such images.
Great. Thank you, Tom. Andreas, next question is to you. How do these methods described in the paper address this domain shift challenge?
We developed two methods for automated data adaptation that can be used to reduce this impact of domain shift and therefore improve the resulting segmentation performance of the already well-performing neural network. So you can use our approaches as an alternative to commonly used transfer learning. The first method is based on heuristic optimization, where our algorithm selects the best combination of image preprocessing algorithms and also generates the parameters for it. So at the end, you have the most suitable preprocessing workflow to convert the images so that they could be used with the already available neural network and produce an improved segmentation quality. The second approach uses an additional neural network, which should learn to convert the images from the one domain to another, so that the images which couldn't be processed by the neural network or would lead to an unusable segmentation result will process so that you get a good quality out of it. The major difference between these two approaches is that the heuristic approach just needs one labeled image and generates the workflow, and the neural network approach would need a lot of data with labels so that the neural network could learn to transform the images. So it's more or less a direct alternative to transfer learning, with the difference that we don't change the model, but instead change the data.
Thank you so much, Andres. That sounds really like a great methodology. I'm sure that there are some potential applications for it, isn't it?
Sure. One suitable situation where you could use our algorithm is when you have an already well-performing segmentation neural network for most of your data, but it doesn't deliver the same quality for one dataset. For example, when you have a dataset from a different imaging setup and you don't have the time and opportunity to create labels for all of these images or for example images of this setup. So you could create a label for one of the images and then use our heuristic approach to create a pre-processing workflow just for this imaging setup, so that data from this setup could be processed with your neural network.
Okay, Sounds great. Well, I'm confident that there will be a wide use of these outcomes. Thank you so much, everyone, for participating in this short but fruitful discussion. And I hope it's going to be informative and thought-provoking for our audience. Thank you, everyone.
Bye.
Bye.